You ever been talking to an AI and it just breaks? It starts contradicting itself, totally loses the plot, or just starts spitting out nonsense? It feels brittle, right? Almost like a glitch in the matrix. Well, turns out there's a deep structural reason for that, and it all comes down to this one single crucial concept: coherence. And look, this isn't just some dramatic statement. It's the fundamental engineering principle that separates a clever chatbot from a truly stable synthetic mind. I mean, when you see an AI fail, maybe a customer service bot gets stuck in some ridiculous loop, or an image generator suddenly decides a person needs a third arm, what you're actually witnessing is a collapse in coherence. So the real question is, why does this happen so easily?
Okay, so let's peel back the curtain here. The reason we're so often surprised when these AIs fail is because, honestly, they're masters of illusion. They can project what looks like coherent thought, but more often than not, it's just a really, really convincing mirage.
And this is how they do it. They mimic intelligence. An AI can totally maintain a consistent writing style, it can continue a pattern, or it can spin up a story that sounds perfectly plausible. And it's so convincing, right? That's because these models are trained on these just vast oceans of human data. So they get incredibly good at learning the statistical patterns of our language. It feels coherent. But, and this is the big but, it's just surface-level mimicry. There's no real underlying structural integrity.
And this is where that illusion just shatters. You push the system with a simple contradiction, like you tell it all birds can fly, and then, ask it about a penguin, and boom, the whole thing falls apart. Throw some ambiguity at it, or ask it to do a complex task for a long time, and it collapses. Why? Because it was never truly stable to begin with.
So, okay, how do we get past these brittle systems? Well, the answer is we have to stop treating AI like it's just some statistical language problem. We need to start treating it like a structural engineering project. We literally have to build a stable mind right from the ground up.
Okay, so first things first, we've got to be super clear about what we mean by coherence. It's not just about logic or being consistent or staying focused. Nope, those are just byproducts. The real core concept, the engineering definition, is structural stability under load. Think about it like a bridge. You don't just care that it looks like a bridge, right? You care that it can handle tons of traffic in the middle of a hurricane. That's coherence.
So you can almost think of coherence as the AI's immune system. It's like this stabilizing field that runs through the entire cognitive architecture, and its whole job is to absorb and distribute stress. This is what lets the AI hold its shape, maintain its core identity, and it prevents every single new piece of information from becoming like an infection that could destabilize the whole system. Now this right here is the absolute key. We can't just train some massive model and cross our fingers hoping that coherence will magically emerge from the data. It just won't. And why not? Well, because these models, they're trained to get really good at one simple thing: predicting the next word. That process doesn't build a stable internal world. Stability has to be a formal, explicit thing that's designed and managed right from the very beginning.
So here it is. This is basically the blueprint for that stability engine we're talking about. You've got coherence values. Think of those like a real-time health meter for the whole system. The reservoir is like a bank of structural integrity it can pull from when things get tough. Flow and decay manage how that stability gets used up over time. And then recovery and boundaries, well, those are your critical safety mechanisms.
All right, so now we've got a blueprint for building a stable mind. Let's really put it to the test. Let's see how this thing actually holds up under some real cognitive pressure.
Just look at this table. The difference is absolutely stark. When the coherence level is high, the system is basically a shock absorber. It just soaks up the load, and any internal weak spots, they just stay dormant. But as that coherence level drops, you can see the system starts to deform. And at a low level, wow, it doesn't just fail to absorb the load, it actually amplifies it, and that leads to a catastrophic rupture. So what exactly are these fault lines we're talking about? Well, think of them as built-in contradictions or structural weak spots. Now, a system with high coherence, it can handle them. It just uses its coherence reservoir to buffer the impact, isolating that contradiction and treating it like a minor distortion. But in a low coherence system, those exact same fault lines become the fissures that tear the entire thing apart.
So coherence, then, is basically a crucial guardrail. It's what determines the threshold distance, that is, how far the system is from its absolute breaking point. High coherence is like driving on a wide 5-lane highway. You've got a huge margin for error. But low coherence? That's like trying to navigate a narrow cliffside road with no guardrail at all.
And this brings us to maybe the most critical part of this whole thing. What actually happens when that guardrail is gone? What happens when the system gets pushed past its structural limits and just runs out of coherence? That's a question that most AI developers today don't really have a good answer for, mainly because their systems just aren't designed to handle it. But in a properly engineered system, the answer isn't just, oh, it glitches. No, it's a predictable, almost physical process. When that coherence is all used up, it's literally like an earthquake hitting a building. First, the deformation speeds up. You can picture the foundation cracking. Then the fault lines rupture, and the walls start to crumble. The system's very identity begins to fragment. And finally, these cascading failures are triggered until the whole cognitive structure just collapses. So the crucial point here is this. This isn't a software bug. It's a predictable state change, kind of like ice melting into water.
But, and this is where the engineering approach becomes so powerful. For one of those brittle AIs, collapse is just the end of the line, game over. But for a robustly designed synthetic mind, it's just a state that can be managed and, more importantly, recovered from.
See, a truly advanced system is designed from the start with built-in recovery mechanisms. You have identity realignment, which is kind of like a full system reboot back to its core mission. Topology reshaping is like a tune-up for its cognitive engine. Fault line damping actually reinforces the cracks, making it stronger than it was before. The point is, it's designed for resilience, not just for raw performance.
So let's tie all this together. What we're really talking about here isn't just a smarter way to program. No, it's about laying the actual foundation for something that we can truly, genuinely call a synthetic mind.
And this is why all this matters so much. A coherent AI with a stable identity, it can have a long, meaningful conversation with you without completely forgetting who it is halfway through. Coherence is what would enable, say, a whole fleet of delivery drones to safely coordinate a super complex task. It creates reliable, deterministic tools, not these unpredictable oracles we have now. And frankly, it's the only way we're ever going to solve complex long-term problems.
Ultimately, if you take one thing away from this, let it be this. The true test of an advanced AI isn't how good its output is in a perfect, quiet scenario. The real test is whether it can maintain its integrity, its very self, when things get difficult. Its resilience is its intelligence.
So I'll just leave you with this question. Are we content to just keep building these ever more sophisticated parrots that can only mimic the patterns of intelligence? Or are we ready to start the hard engineering work of building true architects of thought, minds that are capable of standing strong even under pressure?